All right, good morning, guys. Good morning, Andrew, Kenny, Taylor, Tara, Catherine, Jake, Chris, Jamie, Vandy. Good morning to all you guys. Hope you guys are doing good. A little bit of a change of scenery for me. My wife kicked me out of the our dining room, so I don't have a green screen behind me, so you can just see the beautiful sunlight shining through. Um, this is. Let me actually Let me make sure you can hear and see me. If you can hear and see me, give me a thumbs up just to make sure. Good morning, Maria. All right, cool. Thanks, Sarah. All right, so good morning, Adam. Any questions over, before we get to 5.6 notes, any questions over 5.5 homework? Any questions over 5.5 homework? If you have a question, type it into the chat box now. Okay, Jamie wants to see 10. All right. Maria wants to see 12. All right. Taylor wants to see 6. All right, let's look at number 6 real quick then. Look at number 6. Actually, I need to move some stuff real quick. There we go. I'll minimize myself a little bit. Hey, good morning, Andy. All right, so looking at number 6. Sorry about that. So looking at number 6, it says f times g of -3. So Taylor, I'd want to say -3n plus 3 times -2n squared minus n. All right, we're multiplying f times g. Now, you would have to FOIL this right here, first, outer, inner, last, but it's not saying solve it in terms of n or the variable. It's saying solve it in terms of -3. So in that case, I would not simplify first, and what I would do first is I would simply just plug in -3 to all of our n's. So it should look like this: -3 times -3 plus 3 times -2 times -3 squared minus -3. Should look something like that once you plug it all in. -3 times -3 right here, that would be a +9 plus 3. So that goes to 12 right there. Over here, that's -2. -3 squared would be +9. And then minus a -3. -1 times -3 is a +3. And then -2 is -18 plus 3. -18 plus 3 would be -15. And 12 times -15 would be -180. I don't know if that's the correct answer. Let me check with the back just to make sure I didn't make a mistake. Yeah, that's correct. -180. So I would not FOIL that out. I would just simply plug it in initially. So write down what our problem is and then plug in -3. Does that make sense, Taylor? Okay, so again, just simply take f of n, f of g, multiply them together. But instead of foiling it, like over here, Taylor, you would have to do this right here. You would have to foil this because it says solve it in terms of a. So first, outer, inner, last, right? Over here, you would potentially do the same thing, but since you're solving for -3, you just put -3 into all n's, and then it's just a simple just algebra problem from there, just adding and subtracting. Okay? All right. I think the next question was, if you have a specific question, Taylor, do you have like a specific question about something you don't understand? I'm fine to help you with that. Just let me know what it is. Do you have like more of a specific question about something about 6 or about 5 or? So if you got your second step right, if you did that, that's good. And then from there, if you didn't get -180, you just made a math error somewhere in here. Okay? If you did that and then plugged it in, then you just made some math error through here. So I'd pause the video for a second and I would see, okay, where did I go wrong that Mr. iPod did, where we have something different through here. Okay? That would be my first move if I was you, just figuring out. If you understand this part, you understand the algebra 2 part. But if you made a mistake down here, that's just, just math error. And that's one of the most common mistakes in math is just simple math errors. Okay, cool. Thanks, Taylor. And then going back up here to Jamie said 10. Yeah, so this is the one I started with you guys where we said plug H into G, but G had 2 N's, so you had to plug it into both. All right? So, and I was trying to give you a little bit of guidance on this, but let's come over here and do 3n. So 3n plus 4 cubed. Well, that first is going to look like this. 3n plus 4 times 3n plus 4 times 3n plus 4. You all may need an extra piece of paper for all this. All right? So that's what 3n plus 4 cubed looks like. The first thing I'm going to do is to do these two. Okay? I'm going to FOIL it. All right? And then I'll come back to this one here in just a second. All right? So I FOIL first 9n squared. And then I go outside 12n, inside plus 12n, and last would be 16. So I got 9n squared plus 12n plus 16. Or I meant 24n. Sorry, guys. I forgot to add them. So 12 plus 12 is 24n. Now I have that times this last one, 3n plus 4. Well, there's no way to FOIL this. Now you can distribute 3n into each one and then distribute 4 into each one. Or this is where I taught you the whole ladder, lattice, whatever you want to call it method. Writing one of them horizontal, writing the other one vertical. Okay, so 9 times 3, 9n squared times 3n would be 27n cubed. 24n times 3n, 24 times 3 is 72n squared. 16 times 3 is equal to 48n. 9n squared times 4 would be 36n squared. 24 times 4 would be 96n. And 16 times 4 would be 64. if y'all remember, we add these. You add the ones that are like. So this 3n plus 4 cubed would produce this. 27n cubed. 72 plus 36 is 108 plus 108n squared. 108n squared. And then 96 plus 48 is 144 plus 144n. And then plus 64. So that right there, what we just got from this, so we went from here to here, is just this right here. That just represents that right there, okay? And now we need to say minus 5 times whatever 3n plus 4 squared is, which this is just FOIL, and that's the same thing as over here, which we found to be FOIL, which is 9n squared plus 24n plus 16. So this right here is your setup. That would be your next line after that, if you did all that work correctly. Okay? Now, from there, you got to distribute this negative 5 into everything here. Okay? So I got 27n cubed plus 108n squared plus 144n plus 64 minus negative 5 times 9n squared would be negative 45n squared. 5 times 24 would be negative 120n, and then negative 5 times positive 16 would be minus 80. Then just combine these like terms. 27n cubed, there's no other n cubed, but there is a 45n squared there. So say 108 minus 45, because they're like terms because they both have n squared. You get 63, so plus 63n squared. 144n minus 120, that's plus 24n. And then we have 64 and minus 80. 64 minus 80 would be like terms because they're constants, and that would be minus 16. This is what I think is the answer. And then from there, guys, we just pray that that's the answer that's on the back of the notes. 27, and I'll come back to this. I'm just making sure. 27n cubed plus 63 plus 24, and we would be correct. So that is your correct answer there. That's a tough problem. Okay, just because it brings up this prior knowledge. Do you know how to multiply a trinomial times a binomial? And that just, and some of you guys may remember, just you can do that old school. 8n squared plus 24n plus 16. I taught you two ways. I taught you old school and I taught you this way. So just multiplying that out like that as well. Okay. I know that's a lot, but Jamie, does that make a little bit of sense to you? And to others that probably had the same question? All right, very good. All right, and then I think somebody asked for one more. Maria asked for number 12. So look at number 12. So it says find H composed with G. So that means put G into H. So if H of X is equal to negative X plus 4, G of X is equal to X minus 5, we're going to take G and put it into X. So it look like this. Negative, because that negative is on the outside, times the quantity of X minus 5 plus 4. So put g, whatever g is, into the x of h of x. Now notice this is not for a variable, it's for negative 6. So go ahead and plug in negative 6. So negative 6 minus 5 plus 4. Negative 6 minus 5 would be negative 11 plus 4. That negative 1 on the outside makes that positive 11. 11 plus 4 is equal to 15. I'm going to check, make sure I'm right. 12, yeah, 12 is 15. Okay? Okay. So, Kenny, you said when you're done with 12, can you do 4? Oh, yeah, I can do 4. That's fine. All right. Maria, are you cool with number 12? Okay, yeah, cool. Thank you, Maria. So looking at number 4, so it says g minus f, so 2t. Okay, yeah, no problem, Andrew. 2t plus 2, and then minus f, 4t minus 4. So always make sure, Kenzie, that you put the right side in parentheses, because anytime you have a minus something more than a monomial, you have to put it in parentheses. So then distribute. 2t plus 2 minus 4t plus 4. Now, I just went ahead and did that, but you could have put 7 in there, but now I'm going to put 7 in. So 2 times 7 plus 2 minus 4 times 7 plus 4. So that's 14 plus 2 minus 28 plus 4. Yeah, that'll catch you up right there. No worries, though. It's all right. Then we got 16 minus 28 plus 4. 16 minus 28 is negative 12. Negative 12 plus 4 would be negative 8. I'm just checking, make sure it's right. Negative 8, yeah, cool. Okay. Any other questions with that? Any other questions on 5.5 homework? Good questions all the way around. Any other questions? All right, cool. I don't know if did I ever I'm rocking the I don't know how much you can see it, that the happy. Anybody know who says that? Happy. Who says happy? This is bringing out my redneck roots. Yeah, very good, Andrew. Duck Dynasty people, that's right. Have I ever shared y'all the story about me meeting Duck Dynasty or not? Have I done that? I don't know if I've shared that with you all before. Have I shared meeting Duck Dynasty with you guys? It is Phil. Phil is the actual one. Yeah, very good, Kenny. Tara's saying no, that I haven't shared that story with you. Can someone confirm that? All right. Hey, well, I'll quickly share with you a story of um, the time I got to meet Duck Dynasty. All right. So, and this won't take but 5 minutes, and then we'll jump into 5.6 notes. So, quick story about me meeting Duck Dynasty. Um, Basically, I was going to Louisiana for a church event, a church conference, and the church conference wasn't too far from West Monroe, Louisiana, which is where Duck Dynasty is. So before going, I decided, you know what I'm going to do? I'm just going to look up the Robertsons' address and just go by their house. And I'm going to go by their house and like see if they're like, see if we can see them, see if we can, just wave at them or what, And so I was there with some friends, my wife, and we're all kind of excited about it and everything. And I found the address, which most people's address you can find online, and they're popular people, so someone would probably tell you the road they live on, and they live literally in the middle of the sticks. And I figured it was about a 2-hour drive from where we were staying in. Man, I can't even remember where we were staying. We were staying in Alexandria. It's about a 2-hour drive from there, so we made the trip up, and on our way up there, we kept saying like, yeah, this is dumb. There's no reason to really do it, but we were going to go by the Duck Commander, store and all that, and we did all that, and that was cool. But before we did all that, we were on our way, and Phil Robertson's house was on the way there. So while I was on the way there, I just got this hunch, okay? And it's just, I don't know if it's a gift from God or what, but I got this hunch that we were going to see somebody. I just got this feeling inside of me. You know what? I bet they probably have a gate because, they became so popular that I'm sure people all over the world was coming. So I'm like, you know what? They probably have a gate. But I had this feeling like, you know what? We may see them at the gate. What if we were driving up the same time they were driving up and boom, it was happening. And my friend's like, no, what's the chances of that? That's insane. I'm just like, you know what? I really do think something crazy could happen, And we're like, and everybody was all up for it. And we're like, hey, at least if we see the gate, then we can say we've gone to their house, went as far as we could, to their house. So we're driving down these, it's in the middle of nowhere, guys. And we're driving up down these roads, and then we get to the road at which we would turn to where it would be their road, that it would like literally take us to their road. And when we got on that road, I saw a white truck driving up the road just a little bit from us. All right. And I'm in a van at this time because we had went with several people. And I saw that white truck, and I just floored it as fast as I could to get up to that white truck because that white truck had a Duck Commander sticker on it. And then soon we saw a gate, and the gate was there, and this guy was opening the gate. And I'm flying up there. I then whip this van into a parking lot and jump out and just start waving my hands. I don't know who this is. This could have just been a worker. But then all of a sudden, I saw reverse lights. And this truck backs all the way up to where I am. And lo and behold, it is Phil Robertson. And I about went crazy because for multiple reasons, the hunch was really true. That it's like, man, I felt like this was going to happen, and it actually happened. So that's kind of awesome. But then upon everything, that it was Phil Robertson. Now, I know some of you may be thinking, like, what's the big deal with Phil Robertson? But I don't know. It's one of those times, and I thought, you know what? This is pretty awesome. This is pretty cool. So we actually got to talk with Phil Robertson for about 15 minutes there on his property. And he said they had built the fence, the gate, because so many people were coming to their house and stuff like that. So it's a pretty awesome, pretty unique kind of moment there for us and everything. And this is gonna look weird for a second, but I'll show you the I'll show you our picture with them, just so you know I'm not lying. So there is us. That's me and my wife with Phil Robertson. We chased that man down, and he was one of the most kindest men I've ever met in my life. Very cool guy, very humble. He just got back from duck hunting, so it was a cool kind of moment it was just a cool moment for us. It kind of made our trip, and it was exciting. It was fun, for sure, to kind of say the least. So then we got on this crazy hunch, and we said, you know what? If we've hit the jackpot this good, why not just go ahead and try to see if we can find Cy at his house? Because we knew Cy was, his house was pretty popular. So then we went to Cy's house, and then here is us meeting Cy as well. So, and this is a video. I think this is a video right here, but this is us meeting Cy as well. So, pretty cool moment. It was actually a really cool time for us. And I guess we just got extremely lucky, is all I can say. So that's my story of me meeting the Duck Dynasty crew. So a little bit different scenery for you today than your normal just let's teach some math. So that is my Duck Dynasty meeting story. Those guys were really cool, and it was cool to meet them. All right, so give me a thumbs up if you're ready to go with 5.6 notes. Give me a thumbs up if you're ready to go with 5.6 notes. All right, so here we go. All right, ready to rock and roll with 5.6 notes. Okay, so here's what we're going with 5.6 notes. 5.6 notes is all about inverse relations and functions. Okay, it's all about inverse relations and functions. But here's what I need you to know is basically the word inverse, inverse relations and functions, I guess, is what I need you to know. So, what an inverse function is, an inverse function is a function that changes the x and y coordinates. Okay? So an inverse function is a function that changes x and y coordinates. All right? So it's simply changing x and y. All right? So if you want to find, in order to find an inverse function, your first step is to change x and y. And then second step would be to solve for the new y. All right, that's your main thing today, is that you need to understand what an inverse function is, okay? And an inverse function is just simply something that changes the x and y coordinates. Now, you may be saying, well, what do you mean change the x and y? You're about to see, all right? So, looking at number 1, g of x equals 5 plus 7/5 x. So, this is our function. Now, guys, we can graph this right here. Think about it like this right here. G of x is equal to 7/5 x plus 5. And g of x could be replaced with y. So y or g of x is equal to 7/5 x plus 5. So 5 is our y-intercept. 7/5 is the slope. We can handle that. That's pretty simple, guys. But what it wants us to do is find the inverse of each function. Okay? So let's bring this down here and say g of x is equal to 7/5 x plus 5. Now, as I said up here, this g of x can be rewritten as y equals 7/5 x plus 5. So we can replace g of x with y, all right? Now, you're going to see a notation that looks like this. It says g basically raised to the -1 of x, and that just simply means inverse. That means the inverse of g of x. Okay? So anytime you see that symbol, that's the inverse of g of x. Now, if this is the original function right here, then its inverse, which is this right here, would just be switching the x and y. Okay? So right now the y is here. Right now the x is here. So to do the inverse of it, we make the x, we put the x where the y is, and we put the y where the x was. Do we all see that? I'm switching the x and the y. Okay? So in inverse, you just switch x and y's. So right here, we just switched. We went from the y to being here to the y now being in the x spot, the x being in the y spot. That's the inverse. That's what inverse is. And then what we do from here is we just solve for this y right here now. So isolate everything to the left side and get that y alone. Okay? So the first thing I do to get this 7/5 y alone would be to subtract 5 from both sides. Subtract 5. That cancels. And I'm left with, on this side, x minus 5. I can't combine those. Equals 7/5y. Now, due to many of you not being very good with fractions, and that's just kind of everybody all around, I taught you a trick at the beginning of the year. Then I said, look, if you ever want to get rid of fractions, and right now we have fractions, you multiply everything by the LCD, the least common denominator. The only denominator we have right now is 5, right? So in order to get rid of this fraction, let's just multiply everything by 5. So distribute, distribute, distribute. That would take us to 5x minus 25, 5x minus 25, and that is equal to, now remember this, anytime you're multiplying that least common denominator times something with the same denominator, it's just the numerator, so it'd just be 7y. Okay? And then again, our goal is to solve for the new y, to isolate the new y, so then we just divide all this by 7. That cancels. I'm left with y on this side is equal to 5/7 x minus 25 over 7. Okay, good question, Kenny. Where does the 5 come from? I had x minus 5. Oh, yeah, cool. You got it. X minus 5 equals 7/5 y. I had this fraction, and anytime you want to get rid of fractions, just multiply by the denominator. When I did that, that canceled all those. I end up with fractions, but I didn't have to deal with like dividing everything by 7/5, and that could get nasty quick. Okay. So, but if you did divide everything by 7/5, you'd get the same answer here. And we have y equals 5/7 x minus 25 over 7. And I just move the y to the other side. You can do that. If it's equal to it on the right side, it's equal to it on the left side. So what I'm going to do here is now I'm going to come up here and I'm going to say this. This is our function, but the inverse of this is equal to 5 over 7x minus 25 over 7. Okay, so then it says find the inverse. We've done that. Now just to recap, let's talk about how we found the inverse, all right? So first step was we knew we had this was our function. It gave us this. In order to find the inverse of a function, you switch x and y. So we switched x and y. Then we wanted to solve for this y. So get this y alone. So we started by subtracting 5 and got x minus 5 equals 7/5 y. Now from here, I told you at the beginning of the year, anytime you have fractions and you don't want them, just multiply by the LCM of the denominator. Since our only denominator was 5, I multiplied everything by 5 and I got this line, 5x minus 25 equals 7y. Then I divide everything by 7 in order to isolate y by itself, and then I would end up with this right here. I just move the y to the other side, 5/7 x minus 25 over 7, and that is my inverse right there. So it says to graph these, okay? It says to graph the function in the inverse. So let's graph this one first, 7/5 x plus 5. So this goes back to Algebra 1 days. 5 is my y-intercept, so I put a point there. And 7/5 is my slope. 7/5 is my slope. So I'm going to go up 7 and right 5. Well, obviously I cannot go up 7 and right 5. So I need to go down 7 and left 5, go the opposite way. So go down 7, 1, 2, 3, 4, 5, 6, 7, and left 5 would be right here. Crank out the straight edge. I have a line that looks like that. Okay. So now we need to graph this one. Now this looks a little bit of intimidating, but guys, don't let this intimidate you. We just need to figure out what 25 divided by 7 is. 25 divided by 7 is 3.5. So this right here is kind of like saying negative 3.5. Okay? So my y-intercept is like negative 3.5, which is about right there. And then I just need to go up 5 and right 7. So up 5, 1, 2, 3, 4, 5, and right 7, which would take us a little off the graph, but that's okay. So an inverse is just simply switching x and y up. Now, The beautiful thing about a graph, okay? A beautiful thing about a graph is this right here, is the fact that an inverse is that when you really want to know if you truly have the inverse, draw y equals x on the graph. Now y equals x has a slope of 1 and the y-intercept is 0. So I'm going to do this as a dashed line, and it looks something like this, guys. It's a dashed line, or you could make it really any line, but I'm just going to make it a dashed line just so we can kind of separate it all. Here's the thing about inverses. When you have the original function, this is the original. This is the inverse. This is y equals x. Whenever you have the original graph and you have the inverse graph, they reflect across this line right here, which is y equals x. Okay? So if you want to know if you did the graph correctly, draw y equal x and say, is that a true reflection from there to there? Does it just simply flip over that? Okay? Now, it may be hard to tell at this angle, but in my years of teaching, what I've seen that is if you make this line of reflection vertical, you can kind of see the more reflection that this is just flipped over. Okay? So that's an easy way to always check your graphs. All right. Moving along to number 2. All right. I know that first one can be a little rough, and I didn't mean for it to have fractions. So I actually want to take these out. Take that 7 out of this one. Let's just make this one g of x equals negative 3x plus 5. I didn't mean for those fractions to be on there from the start. So g of x is equal to negative 3x plus 5. All right. So here's what it says. Find the inverse of the function, then graph the function and its inverse. So my function is this right here. G of x equals negative 3x plus 5, which could also be rewritten as y equals negative 3x plus 5. We can change that g of x and y out, no problem. All right? Now, someone tell me what I need to do in order to find the inverse. What I do in order to find the inverse. Someone type it in the chat box. What I do with this equate the original function. What do I switch? I switch what? Someone type it into the chat box. Good, Adam. You change x and y. Okay? So now it reads this. X equals negative 3y plus 5. So change x and y. Now from here, we need to solve for this y right here. Solve for that y right there. So in order to isolate that y, I'm going to subtract this 5 right here. So subtract 5 from both sides. Yeah, we have one more. Hey, did you read the email, Andrew? So we got x minus 5 equals negative 3y. Go back and read that email. It was kind of hidden in there, but yeah, you're going to have to pick up chapter 6. So after this, we have 3 more lessons in chapter 6, a chapter 6 test, and then you have your final. All right. So from here, from this right here, after I subtract 5 from both sides, then I want to divide by -3. Divide everything by -3 in order to isolate that y. Divide that by -3, divide that by -3. So I got here -1/3 x. Yeah, no problem. -1/3 x. And then -5 divided by -3 would be +5/3. We don't, that's a decimal, so we just keep it as a 5/3. And that's equal to y. I like to write the other way, just so, because I think you're used to seeing it more in that form where the y is on the left side. -1/3 x plus 5/3. Okay? Now I come up here and I write g, the inverse of g of x is equal to -1/3 x plus 5/3. All right, so now we just need to graph both. So let's graph this one, -3x plus 5. So y-intercept of 5, and then it goes down 3, right 1. Down 3, right 1. Down 3, 1, 2, 3, right 1. Down 3, right 1. Then I graph my line from there. Okay. Now move to this line. Now again, this looks intimidating because it's a fraction, but let's not trip. 5 divided by 3 is just 1.6. So that is 1.6. So I have a graph, I have a y-intercept of about 1.6. So 1.6 is about there. And then I need to follow my graph, my slope. Now, I like to put the negative with the numerator. That's an alliteration, negative numerator in. So that's the way I've always done it. So I want to go down 1 and right 3. You could do it the other way, putting the negative and go up 1 and left 3. But I always go down and right. So I go down 1. So down 1 and right 3. 1, 2, 3. Down 1 and right 3. 1, 2, 3. And then the opposite would be go up 1 and left 3. 1, 2, 3. Up 1 and left 3. 1, 2, 3. And we have that right there. That would be its inverse. Now, some of you may be saying, well, I don't know, that looks like really funky. How do I know it's its inverse? Graph y equals x, which is just a diagonal line that goes to the origin that has a slope of 1. Graph that line. And if you turn that line vertical, literally make it vertical, you kind of see that this line has just been flipped over. Okay? Or actually, this line right here has just been simply flipped over. So it's a true reflection of what we have here. It looks the same on both sides. A reflection, when you look at your reflection in the mirror, it's the same thing on both sides. So a reflection of this line, it looks like the same. If you look at this side looks the same as that side. Okay? So what you need to know about inverses are the inverses just switch the x and y, and then you have the inverse function of it. All right? Let's go to the back side. Give me a thumbs up if this is making a little bit of sense to you. Okay? We're good? Okay, let's go to the backside now. Looking at number 3. Okay, just got a couple more problems, guys. Hang with me. So, a couple more problems looking at number 3. So, all right. So, let's write down what we have. All right, we have this, the fifth root of x minus 2. All right. So, I want to bring this down here and say g of x is equal to the fifth root of x the fifth root of x minus 2. And we know that we could rewrite that as y equals the fifth root of x minus 2. We can put that y there, and that just kind of helps us kind of see it. Okay? So then from there, we want to do its inverse. So the inverse of g of x. So when we're doing the inverse, we just switch. I know this looks a little funky. I know it has a fifth root, but do what you're taught to do. Switch the x and y's. So x equals the fifth root of y minus 2. Okay, now what we need to do is just simply solve for this y right here, guys. We need to isolate it by itself. So first thing I'm going to do is I'm going to get everything away from it. So let's add 2 to both sides. I got x plus 2 is equal to the fifth root of y. Okay? Now from here, how do I isolate this y right here if it has a fifth root on it? Again, we did that a couple lessons ago. What's the inverse of taking something to the fifth root? It would be raising it to the fifth power. So I got to raise that to the fifth power, and I got to raise that side to the fifth power. Okay? So whatever root's here, raise it to that power, and that will cancel. And then I have x plus 2 to the fifth, and I know you're thinking, man, that's a lot of foiling to do, but we're not even going to foil that. We just wanted to, again, it doesn't say we have to figure it out. It just says find the inverse. So move the y to that side, x plus 2 to the fifth power. Okay? Now, so I have my function up here, and then the inverse function of this is just simply equal to x plus 2 to the fifth. Now, we know what a cube root looks like, okay? We know, you all remember that the cube root of x, again, if I was to show you the cube root of x, remember it's the snake that goes sideways, okay? So the fifth root of x does the same thing, but it's a little bit steeper, okay? It's a little bit steeper. So it basically does the same thing as the cube root of x does up here, but it's just a little bit, it goes a little bit steeper because your numbers are a little bit higher. All right. So the fifth root of x minus 2, if I go to graph that, okay, if I go to graph the fifth root of x minus 2, and I'm fine if you want to use your calculator in order to help you graph a little bit here. All right. So the fifth root of x minus 2, that minus 2 goes down 2. So go down 2, 1, 2. All right? That kind of takes care of that 2 there. And then we just need to graph the 5th root of x. Now, it's always going to be right 1 up 1 for that, for both of those. But then your next number would be 32. So it'd be like this, going up 2 and right 32. So what I would do, guys, is I would just graph it from here and go draw it just like that. Draw extremely steep, all right? So it looks just like the cube root function, really, if you kind of think about it. It's just the next time it's the cube root hits the next one at 8. It goes up 2 and right 8. But this one goes up 2 and right 32. So it's extremely steep. I'm not looking for anything perfect, guys. I'm just looking for a decent looking graph, a good approximation. So that's that right there, guys. Now let's come over here. Now, you all know that x cubed, you remember how we talked about these being really similar? X cubed does that right there. Well, x raised to the 5th power, guess what? Does the same thing, but it's a little bit steeper now. This is x to the 5th power, so it looks very similar to x cubed, okay? So it looks very similar to this. It just runs a little bit steeper, all right? So in order to graph this right here, plus 2 on the inside, that means go left 2 first. Go left 2. And then it's always going to be up 1, right 1, up 1, right 1. And then your next one would be right 2, up 32. So again, just like this one, it's just going to be really steep, guys. Same thing here. Once it touches that 1, it's going to drop down quick and be really steep. My main concern is that, and your main concern for your test is because I can't have you graph stuff, just because obviously that would be an absolute challenge to graph something, then you send me pictures. But you're going to have the ability to do this, okay? I don't know if photo math and a lot of that stuff allows you to do that, so I don't know if you're going to be able to put your camera right up to the problem on the test and then give you the answer. I'm not sure it could. I don't know. It may be able to find inverses. Don't know. But I think you guys have the ability to do that. And again, using photo math will do nothing. If some of you guys are seniors in here, so seniors, you know, the more power to you. But the rest of you, Lord have mercy on your sake. Because you're just going to be right back in school next year. All right. So, and then guys, remember, if you ever want to graph, just graph this line right here, that y equals x line. And if you make it go vertical, you can see that true reflection. It looks the same on both sides. So that shows you that our function, that our inverse function is correct, because if it reflects across y equals x, then it's the inverse function. Okay. So, looking at number 4. This will be the last one we work today. Let's not even worry about number 5, okay? So, number 4. Our function is 1 plus x to the 5th. Now I'm going to rewrite that as x to the 5th plus 1. It's the same thing. So g of x equals x to the 5th plus 1, which is the same thing as y equals x to the 5th plus 1. So, in order to find the inverse, guys, what we want to do is just switch x and y. So we say x equals y to the 5th plus 1. So from here, guys, we want to isolate this y right here. So first step is subtract that 1. So x minus 1 is equal to y to the 5th power. And then what do we do to get that 5th power off that? Well, what's the inverse of raising something to the 5th power? Taking the 5th root. And what I do to one side, I have to do to the other. The 5th root and the 5 cancel, leaving me y equals the 5th root of x minus 1. Again, our main goal is to get that y by itself. We've done that. Now I like to rewrite it as that as the 5th root of x minus 1. So I come up here and I'm going to say that's my function, and my inverse function is equal to the 5th root of x plus 1. Okay? Now let's graph. 1 plus x to the 5th. Remember, x to the 5th looks just like x cubed, but it's a little bit steeper. 1 on the outside makes it go up 1. So go up 1. And then it's always right 1 up 1 and left 1 down 1. And then it's just going up extremely fast and going down extremely fast. So that's the g of x. It's just x to the 5th, which looks just like x cubed. So if I was to ask you guys what does x to the 7th look like, well, guess what it looks like? It looks like just the same. It's an odd power going up. Okay? It's an odd power going up. Oh, okay. Kenny, the plus 1 right here, it's on the outside. So remember with functions, when it's on the outside, remember on here on the inside it goes the opposite, but when it's on the outside it goes up. It's a vertical translation, so this goes up 1. So we went plus 1, and then we do our graph from there, our just approximated graph. Okay. Now let's do this one right here. Oh, okay, my bad. It's minus 1. No, you're cool. No, thanks for telling me, because I would have made that mistake. All right, yeah, because I'm about to work this one. So x minus 5, it looks just like x to the 5th, but it's going sideways. So x minus 1 it goes to the right 1. Since it's on the inside, it's opposite, so it goes right 1. And then, like I said, it's the same thing but sideways, guys. It's the same thing, but it's sideways. And as you see, if we had our line right there, that y equals x line, that's me just rough sketching it. You can obviously tell that that is a true reflection. So that means you've done it correctly. Easy way to kind of check it to make sure your graph is right and that you got the right inverse is just, I'm fine with you typing it into your calculator. So 1 plus x raised to the 5th. And the other one is the square root, or the 5th root. So you would have to go to math, and then it's that number 5, and it's the 5th root of x minus 1. And you just graph both of those, and then you should be able to see that that is what we have. Ours looks a little different. Obviously, ours is just a rough sketch, okay? Ours is simply a rough sketch. Their graph is a little bit more spread out. That's a 10 by 10. By 10, we got a 6 by 6 by 6 by 6. So obviously it looks a little bit, we could change our window a little bit to kind of adjust for that to make it look a little bit more similar in order for you to kind of see it within itself. Again, ours is just kind of a rough sketch. Theirs is a little bit more accurate. Okay? Okay, now you may be saying, well, what does the graph have to do with this? An inverse is just another property of a function, guys. And your goal is to know at the end of Algebra 2, basically a lot of properties of functions. An inverse is just another property of functions. You've learned domain, you've learned range, you've learned end behavior, you've learned asymptotes, you've learned a lot of stuff. And this is just another thing about functions, is the inverse. Okay? So that is that. We don't have to worry about 5. I think that those 4 problems would be pretty good for you guys. How do we feel about it? Just take some time. It's a little tedious, but give me a thumbs up if you're feeling okay about it. Okay, cool. So, looking at your homework. Okay, looking at your homework. I'm gonna try to see if I'll see if we can let me change some of these problems. He gone. Chocolate milk boy, you gone, boy. All right, so looking at these, let me change some of these. All right, I want you to change them too because it'll make it much easier on you guys. So change the first one to g of x equals 5x plus 5. Okay, g of x equals 5x plus 5. Change this one over here to f of x equals negative x minus 3. All right. Change that to f of x equals negative x minus 3. This will help you. I'm wanting you to get better with your understanding of what's happening. Okay, opposed to, and again, so when you do your thing, y equals 5x plus 5, and then you do your inverse of g of x, and you just switch them. X equals 5y plus 5. Okay, so just give me an example of what that looks like, and then you just solve for that y. Okay, over here, negative x minus 3. 3's fine, 4's fine, 5's fine, and I don't want you to work number 6. So you got 5 problems for homework. You can knock that out. Then I'll meet you here Wednesday for the study guide. How does that sound? Give me a thumbs up if that's making sense to you. Cool, Tara. Very good, Kenny. Thank you all. Thank you, guys. Thank you, Molly. If you all don't have any other questions, that's it from me today. I hope you guys have a wonderful day. And that's lesson 5.6. Feel free to rewatch it. If you have any questions, I'll be on here for just a couple minutes. So other than that, you all have a great day. Good to see you. Thank you for being in class today. Thank you for your continued commitment to my class. It means a lot to me. So thank you so much. And then you guys are good to be dismissed. Hope you have a good day. Yes. Thank you. You guys have a good day. You too, Karen. See you. See you, Maria. See you, Jake. See you, Taylor.